Okay, so in this video, we're going to be making a simple simulation for states of matter. So it should be a little resource you can use either in science lessons, so maybe science teachers could use this, or you could use it in computer science lessons, IT lessons, and apply it to, obviously, science. So you're still teaching the programming concepts, but using another topic, a cross-curricular theme to actually do that. So, first thing I'm going to want to do is, in this uh, program, I don't want the cat. So I'm going to delete the cat by clicking on the bin icon down here. And then what I'm going to want to do is create a particle, or an atom, whatever you want to call it, which is just a circle. And because it's just a circle, what I'm going to do is, I'm not going to click choose a sprite. I'm going to paint one, which opens up the editor. I'll keep it as purple. And then I'm going to make a circle. And a tip for doing this, if you hold down shift on your keyboard whilst you make a circle, it makes it a perfect circle rather than if I leave go, it makes like an oval. So it keeps it perfectly as a circle. And then you'll want to drag it so that the center kind of locks on to this center here, just to keep it in the center of the image, basically. Okay, so I've got a particle. Now, what I'm going to do here is a lot of the logic for the main program is going to be kept in the stage. So you can put scripts, instructions in the particle. As we can see, if I put anything in here now, any blocks in here, it's instructions for this sprite one, this atom. But if I click on backdrops, now this is highlighted. I'm just putting instructions in here that get carried out. It's not related to any particular sprite, but it could be related to the background in some way. So what I want the program to do is, I would like it that when we click the green flag, it asks for a temperature, and then judging on the temperature, we're going to base it on water for this one, it'll decide which state of matter the atom on the screen should be in. And then the atoms react to that. Okay. So I'm going to start off with when green flag clicked. I'll just zoom in for you to see. And the first thing I want the program to do is ask a question. I want it to ask. So in sensing, you can find the ask block. And I want it to ask, what is the temperature? Okay. And then I need 3 possibilities here, because I need to see if the temperature is going to be equivalent to the state of matter being a solid, a liquid, or a gas. So there's 3 possibilities from this question. And because there's 3 different possibilities, not 2, I'm actually going to have to do something that isn't, and you can't do it in a very nice way in Scratch. So this if-else block gives me 2 possibilities. A condition is true or it's false. But I actually want to do 3. So if I can put another one inside the else like this, now there's 1 possibility will come here where we can put instructions for if the first condition is true. And if it's not, we can check a second condition, and if that's true, it'll go to this instruction, whatever I put in here. But if both these conditions were false, then it'll do whatever's inside this last space for an instruction. Okay, so my first condition is going to be if the temperature is less than 0. So we're basing it on water. So I need a less than symbol. You'll find these comparators, we call them, because they compare 2 values. You'll find it in operators. So there's less than. And I want less than, we'll put 0. I mean, at 0, it should technically be solid. You could put less than 1 if you want. But I'm just going to leave it at 0 for now. And the value that goes in here is the answer. The answer to the question. Whatever is typed in by the user will be compared if is it less than 0. So what do we do first if it is less than 0? Okay, well, what I want the program to do is send a message to all these sprites, so the atoms. I should probably name this, rename it to atom or something like that. Okay. I wanted the game to send a message to all the atoms and for them to react to it, to do something in reaction, as a reaction to that. So what I wanted to do is broadcast a message. Okay, it's like a secret message. It doesn't actually display on the screen. It's not a message for the user. It's a message for the sprites in the game. And I'm going to change the message by clicking on this. And I'm going to call this solid, because if the temperature is less than 0, the water will be solid. Okay, it'll be ice. And then I need to think about what do I do if it is a gas. I'm just thinking, is this the best way to do to lay this out? So if it's not less than 0, then we check, well, is it more than 100? Okay. So if the temperature is not less than 0, it means it must be either equal to 0 or more than 0. And that's fine. That means it's going to be either a gas or a liquid. So we need to check now, is it more than 100? If it is, then we're going to broadcast gas, because if the temperature is more than 100, it's going to be a gas. And if it's not less than 0 and it is not more than 100, it must be in between. And the state of matter in between a solid and a gas is a liquid. So we can call this liquid. Okay. So we've got the, what do you call that in English? The melting point. Okay. And we've got the boiling point for water. So this is specific at the moment to water. And now what we need to do is get the atom to react to all of these messages. Okay? Because it doesn't behave the same way as a solid, a gas, or a liquid. It behaves differently. So let's go to the atom. And now what we can use, because we've created those 3 different messages, there's a block called when I receive. Let's zoom in again. And I'm going to do maybe when I receive solid for now. What do I want the atom to do when it is in the solid state? Well, when an atom is solid, it barely moves. It does vibrate a little back and forth, but it hardly ever moves. I'm going to keep this very simple for now. I might make it more difficult towards the end, or not difficult, more complex. And what I wanted to do is just change, maybe move 10 steps. So it's going to move in one direction. And then I wanted to move minus 10 steps. So it moves back to where it was. Oh. Now what happens when I do this? It looks like nothing's happening because it happens so fast. It goes through these instructions that I can't actually see it. It moves 10 steps right and moves 10 steps left before it gets displayed on the screen. So you don't see the change. So what you can do in control is you can make it wait a second or an amount of time. So it moves to the right first, 10 steps. Oh, sorry, let's click this. And then moves back. Moves to the right, moves back. So you can see it doing it. And you can change this to be maybe 0.5. Okay, and what we wanted to do is to keep doing that. So we just put that inside a for a loop. And it looks weird because in between these two it waits 0.5, but once it goes to move minus 10, it goes immediately back to move 10 steps. So it actually does that faster. So we need to put another wait block. I'm right-clicking and clicking duplicate to get these blocks, okay? And now it just kind of goes back and forth a little bit. If you want to develop that any further, you don't have to, but it'd be nice if it wasn't just going back and forth. The atom can vibrate in all directions. So what we could do is, because these move steps always just moves in the direction that you're pointing, and the atom or sprites in Scratch, by default, they point to the right. You can see the direction is 90. Okay, and you can change that. So what we could do is we could use this pointing direction and combine this with a pick random. Okay, and we can pick a random angle between 1 and 360. So then, by putting this in here, now you can see it kind of vibrates in all kind of directions. If we make it no less time, then we start to get a much nicer kind of movement of the particle. Maybe 5 steps would be better. And -5. And then it's up to you how much you can play around with this to make it a bit better, or it doesn't really matter. It's still doing the same thing. Okay, so what I've done there is I've made a behavior for the atom when it's solid. And that's fine, we'll keep that as it is. But I also need it to be able to do something when it's a liquid and a gas. So I'm going to duplicate this very quickly. Right click, duplicate, and then place it. Change this to a liquid. And then I am going to take out all the code because we don't want it to behave in the same way. We want it to do something different. So what should we do? When we need the particle in a liquid, it kind of moves around sort of slowly, but it isn't stuck in one position. It's not trapped in one position. So we just kind of want it to go, well, move in one direction. And then we want it to bounce off the walls. We don't want them to just get stuck against the walls of the screen. And there's a block in Scratch, which is always hard to find. It's in motion. It's called if on edge bounce. So we put that in there. Once it's moving around, it's moving, and it goes back, and it keeps moving around and around. Well, not run around, sorry. It keeps moving in one direction. If it touches the edge, this block makes it bounce back. So at any point, if it touches the edge, it bounces back. Okay, and maybe that's a bit too fast for a liquid. So maybe we'll change it to 5 steps, so it goes half the speed. So each time it does this block, it's only moving 5 steps, 5 pixels across the screen. Okay, and that's basically a liquid. How does it differ when it's in a gas? Well, not very much. The main thing is that it just goes faster. So we'll just double it. So that's a gas. Oh, that's a liquid. Okay, so what I'm doing here is just clicking on the top blocks to test out each behavior. Because if I click the green flag, that's actually going to ask the question again. But that's a handy tip if you want to test something quickly. Just as one small script, just click on the top block. If it's an event block, that is. Okay, so we've got a different behavior for each of these messages. And now all I need to do is actually run the program, because we set this up now. It's going to ask me for a temperature. And based on the temperature I enter, it compares it to the values for the boiling point and the melting point of water. And then the atom will behave in that way. So let's put in -10. And you can see it shows that the solid is lit up, and that is what the behavior that it's doing now. Let's try again, and this time let's put in 10 degrees. And it's a liquid. And then let's try again. What if it's 110 degrees? Oh. Now it's a gas, it's moving a bit faster. So we've taken what is quite a simple program, but we've used user input, we've used selection, we've got nested ifs, else blocks, we've got repetitions in there. We've done loads and loads of programming concepts, but we've applied it to a cross-curricular theme, to something that is quite an abstract concept. And that's why Scratch is so good, because you can apply it to simulate abstract concepts, especially in science, as well as developing your programming skills to do it, which is why I think this is a really nice activity. So if you want to do extensions to this, then you can actually get kids to think about, well, this works for water, but what would be different if it was maybe a metal? I'm trying to think of a good example. Maybe what if it was lithium? Okay, or mercury. Mercury is probably a better idea because it actually is used in thermometers. Well, then they'd have to think about, well, what's the boiling point and the melting point of mercury, and how would I adapt this? Well, the only thing I would need to change is change these two values. So if I don't know what the boiling point of mercury is, I'm going to just assume that it's minus 50. Tell me I'm wrong, because I am definitely wrong. And let's say, sorry, I meant melting point earlier. Yeah, boiling point, well, it must be quite high. I reckon it's probably 150, at least. Okay, so now that's going to change the program. So pretend that those are the correct values. If I put minus 60, it's a solid. But if I put in minus 10, now it's liquid. If I put in 170, then it's a gas. Okay, so you can extend it in that way. You could even, there's a couple of ways of doing this. I usually find with primary kids, depending on, well, primary and lower secondary, depending on how much time you've got, you could just tell them to right click and duplicate, and that just makes exactly the same atom. It's got all the same instructions inside it, and you can do this a few times. This isn't the best way in terms of programming to do it, but, and you can see it's not random enough. Okay, they're going to move in groups, which we don't really want. So one way you could fix that is just at the start of liquid and gas, you also put this point in direction, but before you get into the loop. So when it first starts moving, it picks a random direction. But in the forever, it doesn't move 5 steps and then pick another random direction. We want it to carry on going the way it was heading. So you can put it in before the forever loop, just to stop that behavior of grouping together. Okay, they still did that. Oh, and then that's the issue with clones that I was about to say, actually. Because I've changed it in one, it doesn't change it in all the others. So I'd have to delete the rest and then reclone this one. I shouldn't use clone, sorry, copy of them. There is a better way where you do use something called clones. But you can see now that that code is all the same in all of them. It's quite a nice simulation. If I make it a gas, they move faster. And as a solid, they kind of just vibrate together. A better way to do this copying, which again, I wouldn't recommend because it's not really nicely done in Scratch. So it's easier generally just to copy them. But what you can use is when I start as a clone. Okay. Oh, sorry, not that. Create clone of myself. So if I just put that in when green flag clicked. Okay, so when the game starts, it's going to clone itself once. So if we do that, there's going to be a clone of it underneath that one there. Okay, and depending on how many clones you want, you could just copy and paste that, but you don't want to do that because you're a knowledgeable programmer. You wouldn't do this. You would use a repeat block. And I'd get a repeat block from control. Say I want 10 clones, then I would put that there. And now we've got 10 of them. And that is a better way of doing it because you don't have different codes or the ability to change different codes for different sprites. You just have the one sprite with the one set of instructions, and you're cloning it because it behaves in exactly the same way. Okay, and that's a nice program. So another example of cross-curricular applications for Scratch and programming. So hope you enjoyed that and hope it was useful. I'll be doing some more cross-curricular Scratch games, which you'll find in this playlist on YouTube.